Topic 1-1, solving one-step inequalities. This can be referenced with our Holt textbook, Chapter 3, Section 2, on page 174, and also Chapter 3, Section 3, on page 180. Okay, dealing with inequalities. You're determining if these are true or false, and you know that 4 is greater than 2, but we can prove it. If you add the same thing to both sides in addition property of equality, it would also show that 7 is greater than 5, and that's also true. So we're just proving it by doing the same thing. You can actually do it by subtraction as well. If you subtract the same thing on both sides, 1 is definitely greater than a negative 1, so that's also true. Showing that 4 is greater than 2 even through multiplication property. If you multiply the same thing to the two numbers and also prove another number greater than another number, then this makes this statement 4 is greater than 2 true. Okay, let's look at another example. If you said 4 is greater than 2 and you multiplied by a negative, then this is where it comes into play that it's not true, because a negative 12 is not greater than a negative 6. So this statement would be false. Likewise, in division, you would come up with a true statement, but if you divide by a negative, you end up with a false statement. Thinking of a number line, a negative 2 is further down the number line to the left than a negative 1. So therefore, there are, out of these 6 ways of adding, subtracting, multiplying, and dividing, notice the 2 that are false statements are when you divide by negatives. So our conclusion can be that when you multiply or divide by a negative number, you can make sure you write this down for your notes, but if you multiply by a negative number, you have to change the inequality sign. So this little review of things that are true or false hopefully will make us remember that when we divide by negatives, we're going to flip the sign. They say change meaning if it went this direction, you're going to flip it and make it go another direction. Okay, we're going to solve a few inequalities. Let's just do, I already have them worked out, but I just want to talk about them as you copy them down. If you're trying to isolate the y, you want to add 2 to both sides, therefore making this go to 0. You bring down your y, the inequality stays y is less than 8 when you add these two together. To graph this along a number line, you only really need to put 1 point. If you want to show me where the 0 is, that's okay too. But you draw the line. This inequality is an open inequality as far as the circle goes, and its y is less than 8. So everything goes this direction. I have a little picture that I use to try to show kids this, and that is, I'll just use my card. If you have an inequality of greater than and less than in an open circle, we'll get in later in this unit into inequalities with graphs. It also will be a dotted line. So he's kind of my clown. And then also, if you have an inequality that's greater than but also equal to, less than and also equal to, the line that you graph will have a circle closed in. And when we get into coordinate planes, you're going to have lines that are solid lines. I'll make that one straight across. He's not as happy. I always think of him as my Rudolph. Sometimes I'll make this red. But this shows greater than, but also equality. So if you think about his eyebrows and his eyes. But that refers to also equal. So just a little visual to help you remember that. You can add that to your page if you'd like. Okay, so let's look at the other one. If you've got an r on both sides and a constant on both sides, then you're having to look at getting your r's together Sometimes I'll have students draw an imaginary line through their inequality. This one's not quite lined up, and then think of it as a balancing act. You're wanting to balance out your equation. So by subtracting a 2r on both sides, this goes away. This becomes r. Carry down your 17, bring the 14 down. You're still wanting to isolate this variable, so you're going to subtract 17 on both sides to do that. You're wanting this to be alone. Always think about getting your variable by itself. You wouldn't subtract a 14 and bring it this way, because then you're still going to have a constant next to your variable. But after subtracting, if it helps, cross out what goes away, carry down the r. It's still greater than or equal to a -3. Therefore, graphing it, you're going to have a solid circle because it shows the inequality. It's got the eye and the eyebrow, if you want to think of it that way. And your line goes this way. Some students actually put it on, and that's okay too, put it on the number line that you draw, and then just make this a little bit heavier. You can do that. So either way would be okay. Above it or on it would suffice. Okay. Let's go to the next page. I'm going to cover up some of them. Let's look at just number 3. All right, again, 9t on both sides. This one, I'm just going to show you what happens if you end up choosing to subtract the 10. You're going to end up with a negative variable. With a negative variable, you will end up having to flip the sign in a minute. So this goes away. Carry down the operation of 9 and a -10 gives you a -1. Plus 5 is less than or equal to a -3. We want to move the 5 away because, again, you're trying to isolate your variable, the t. So the 5 is subtracted on both sides. Therefore, this becomes a -8. You've got to remember your integer rules. 2 negatives, you're at a negative line, and you're just walking down 5 more to the left on your number line. 2 negatives combined together are still negative. However, this has to be division of a -1, and when you divide 2 negatives, it becomes positive. Lots of integer rules, having to remember the difference between combining 2 negative numbers and multiply, divide, dividing 2 numbers. So again, review with me if you need a little bit more explanation on that. But t being greater than or equal to 8 is going to be a solid line going this direction. The only thing needed done in number 4 is division, but again, you had to remember to flip the signs. So I'm going to highlight that. We forgot to explain that on that one. That had to flip because we divided by a negative. You divided by a negative, so the sign flipped. So it's less than, and it goes that direction. Take a minute, do these problems on your own, 5, 6, and 7, and then I'm just going to leave this here. You can pause it and check your answers. And that concludes 1-1. Please ask your teacher if you have any more questions.